Hi, in this video I'm going to discuss Edexcel IAL Mathematics Mechanics M2 October 2022 paper. All the questions will be discussed in this video. Okay, so the first question based on center of mass. What should you know based on center of mass? Again, I'll quickly revise it. So, if you want to find the center of mass of system of particles relative to a point, for example, if there is a mass m1, then its distance from a point O is r1. There is another mass m2, its distance from point O is r2. There is another point mass m3, its mass distance of that point mass is r3. So center of mass of these system of particles, there is lot of particles, there is a point with a mass mn, its distance from the origin is rn. Okay, if you want to find the center of mass of this n system of particle from point O, it's given by R is equal to m1 r1 plus m2 r2 plus up to mn rn over total mass m1 plus m2 up to mn. We normally write this sigma mi ri I is equal to 1 to n divided by sigma mi total mass I equal to 1 to n. This is from a point. But at the same time, you can find the center of mass from a particular axis. Say, for example, you can find the x coordinate of the center of mass. Also, you can find the y coordinate of the center of mass. For that, this is the center of mass I found from a point, but you can find the distance of center of mass from an axis. Say, for example, if this is y-axis, this is x-axis. Right, there's a particle, its mass m1 at a distance x1 from y-axis. So, x coordinate of the mass m1, the point mass m1 is x1. There's another particle m2, its center of mass x coordinate x2. There is m3, its center of mass x3. There is n particles, so nth particle, its mass fn, its center of mass xn. So the x coordinate of the center of mass is given as x bar is equal to sigma mi xi over sigma mi, that is m1 x1 plus m2 x2 plus up to mn xn over m1 plus m2 up to mn. Okay, same way we can find the y coordinate of the center of mass also, because when we find center of mass from an axis, we won't be able to find the actual point. We can say, for example, when you solve this x bar, it comes as, for example, when you solve with the numerical value, the x bar, the final center of mass, is, for example, 2 meters. So what do you understand by this 2 meters? That means from the y-axis, it is at 2 meter distance. So we don't know the actual distance. So center of mass is at 2 meters, means this is 2 meters. This length is 2 meters. So the center of mass is on a point on this line which is at 2 meters from the y-axis. But we can't find exact point of the center of mass when we find the center of mass from an axis. But if you find the center of mass from a point, something like O, then you can find the actual point of the center of mass. But when you find the center of mass from an axis, you won't be able to find the actual point of the center of mass, but you can say the distance of the center of mass from the y-axis. That means it will be, the center of mass will be on one of the point on this line which is at 2 meters from the center of mass. Okay, so but if you want to say, for example, if they ask you to find the x coordinate of the center of mass, for example, you found 2 meters, but you can't find the actual point, then what should you do? You have to find the center of mass for the same system of particle from the x-axis, that is y coordinate of the center of mass. You should find that approach, we need it in certain questions. So then you need to find the y coordinate of the center of mass of the system of particles That means from the x-axis. When you find it from the x-axis, you are getting 3 meters. So 3 meters means the center of mass is at 3 meters from the x-axis. Means I made 3 meters on this line. So in this line, this is 3 meters. So now I can tell the point center of mass where the two lines intersect. This is the actual center of mass. So when we find the distance of the center of masses from both y-axis, that is x coordinate of the center of mass, and y coordinate of the center of mass, then we will be able to find the actual point of the center of mass where the two lines intersect. That will be the actual point of the center of mass. Okay, so there are, again, one more thing you better to know. There are n system of particles available on a plane. So the center of mass, the x coordinate of the center of mass of this system of particles is given by x bar is equal to, we know that sigma mi xi, that is m1 x1 plus m2 x2 plus m3 x3 plus up to mn xn over m1 plus m2 plus up to mn. Okay, so that we write the sigma mi xi over sigma mi. Oh, that is x coordinate. Okay, now from this system of particles, a particle is removed. A particle is removed. What will be the center of mass of the new system of particle after removing a particle? After removing a particle, what will be the center of mass, new center of mass of the remaining particles? We can give it in terms of earlier center of mass. For example, now this M3 is removed. So when M3 is removed, the remaining particles are M1, M2, up to M4, up to Mn are the particles remaining. Okay, so this sigma mi could be written as capital M. So that is sigma mi xi over capital M, we can show that's a total mass. So that is mx bar for the initial system of particle when there is x3 also is equal to sigma mi xi. Okay, so the new center of mass after removing the particle m3 from the system, the new center of mass will be given as x1 bar. So that will be x1 bar will be given as m1 x1 plus m2 x2 plus m4 x4, because x3 is removed, up to mn xn over m1 plus m2 plus m4, m3 is not there, it's removed, plus up to mn. That's a new center of mass of the particle remaining after m1 is removed from the system. Okay, so how can we get x1 bar in terms of x bar? Okay, from this one, that is mx bar minus m1 m3 x3, if I subtract m3 x3 is equal to, from the right side if I consider, that is m1 x1 plus m2 x2 plus m4 x4, because m3 x3 has come to the left, m4 x4 up to mn xn. Now divide the whole equation by m1 plus m2 plus m4 like that. So that is mx bar minus m3 x3 over m1 plus m2 plus m3 is not there, removed, m4 plus up to mn is equal to m1 x1 plus m2 x2 plus m4 x4 plus up to mn xn over m1 plus m2 plus m4 plus up to mn. This is going to be x1 bar, x1 bar. So that means mx bar minus m3 x3, the removed particle m3 x3 is equal to the remaining total mass, that is m1 x1 bar. We can use this idea whenever a portion is removed from a system of particle. We can relate the new center of mass, that is x1 bar, into m1 is the total mass remaining after a particle m3 is removed. So x1 bar into m1 is equal to initial total mass before removing into the initial center of mass minus the particle which is removed into its earlier distance of center of mass from the axis about which we are measuring. So we can use this idea in certain situations easily when a portion is removed from a initial given system of particles or given object. Same way when you add a new mass with the initial mass mx bar, you can say for example a new particle is given n plus 1, that is n plus 1 at a point x n plus 1 is added. So the new center of mass m2, the total mass m2 is equal to, after you add a new mass particle, into x2 bar. This way also you can find the new center of mass in terms of the initial center of mass when a new particle is added to the system of particles. We can use these things in certain questions. Okay, so first question, three particles of masses 2m, 3m and 4m are placed in the points with coordinates -2, 5, 2, -3 and 3 kk respectively, where k is a constant. So here the particles, both x coordinate and y coordinates are given. For example, for the first particle which has mass 2m, its x coordinate is -2 and the y coordinates is 5. Okay, show that x bar is equal to 2 plus 12k over 9. It's not a big issue. We can show that as by using the theory what I explained. Now we can show that. Okay, so if I write the given data, that is 2m particle is at a coordinate of -2, 5. The particle which is 3m is at a coordinate of 2, -3, and the particle which has mass 4m is at a coordinate 3k, k. So this is x coordinate, this is y coordinate, x, y, and this is xy coordinate. So they asked to find the x bar, that is center of mass of these three particles. They are x coordinate they are asking. So a part, we know that x bar is equal to sigma mi xi over sigma mi. Okay, mi xi. So for the first particle, 2m into -2 plus 3m into 2 plus 4m into 3k over m1 plus m2 plus the total mass, that is 2m plus 3m plus 4m. Okay, so all the m will get cancelled. Solve it. This is going to be -4 plus 6 plus 12 over, all them get cancelled. 3 plus 5, 9. So it's going to 12k. Yeah. It's going to be -2 plus 12. Yeah. 2 plus 12k over 9. That's the A part answer, x bar. Then the center of mass of the three particles lie at a point on the straight line with equation. So, right, I told you that we can find the x coordinate of the center of masses, means that will be on a line which is parallel to the y-axis, but we don't know the actual point of the center of mass. I explained when I was before starting this question. Same way we can find the y coordinate of the center of mass, means the y coordinate of the center of mass will be parallel to the y-axis. That means we can measure from the x-axis. So when these 2 points cut each other, intersect each other, that will be the actual center of mass. Say for example, if there are two, these are the x and y axis, Cartesian coordinates. This is the x bar. along this line, the center of mass will be at one point. This is the y bar. That means this line is the y bar. Somewhere in the center of mass is on this y bar. Where the 2 points cut, that's going to be the actual center of mass. Now, this point could fall on a straight line with an equation, for example, x plus 2y equal to 3, like that. They are saying this center of mass is falling on it. So, this center of mass, if I say the center of mass, for example, x bar, y bar is the center of mass, means when I substitute these values here, x bar plus 2 y bar must be equal to 3, because that center of mass is on this line. So when I substitute the coordinates of the center of mass in this equation, that should satisfy this equation. So that's the idea we are going to use now for the B part. Okay, so we'll find the y bar of the, that is y coordinate of the center of mass of the given 3 particles. Y bar equal to, we know that sigma mi yi over sigma mi. So mi yi, so that is 2m into 5, 2m into 5 plus 3m into minus 3, 3m into minus 3 plus 4m into k, 4m into k divided by total mass, that is 2m plus 3m plus 4m. So solve it, all them will get cancelled. So you, when you solve it, you will get, that will be 1 plus 4k, 1 plus 4k over 9, that is a y bar, y coordinate of the center of mass. X coordinate of the center of mass is this one. Now these 2 points should satisfy the equation given x plus 2y equal 3. So x plus 2y equal to 3. So that means x bar plus 2y bar must be equal to 3, because these 2 points should fall, is falling on this line, the question says, means these 2 coordinates should satisfy it. So that means x bar plus 2y bar must be equal to 3. X bar we can put 2 plus 12k over 9 plus 2 times 2 into this one, so 2 plus 8k multiplied by 2, 2y bar means 2 plus 8k over 9 must be equal to 3. Okay, solve it to find the k. You will get 20k equal 27 minus 4. So k will be equal to 23 over 20. The question is find the k, 23 over 20. That's the answer. Okay, second question. A car of mass 900 kilogram is moving down a straight road which is inclined at an angle alpha to the horizontal, where sin alpha is given 1 over 12. So we can find tan and cos or tan whenever we required. The engine of the car is working at a constant rate of, that is power, 15 kilowatts. The resistance to the motion of the car is modeled as a constant force of 400 Newton. Find the acceleration of the car when the speed of the car is 16 meter per second. Okay, I'll show this information on the diagram. So this is the car moving down at a speed of 16 meter per second. And there is a resistive force, that is 400 Newton. The component of the weight will act along the slope down, mg sin alpha, you must know that. In my previous papers, I already explained. The component of the weight will act along the slope, which is equal to mg sin alpha. And the component of the weight perpendicular to the slope is given by mg cos alpha. Remember that. The mass of the car is 900 kilograms, that's given. The power output of the car is 15 kilowatts. And also it's given sin alpha is equal to 1 over 12. Okay, so we need to find the acceleration. So we can use Newton's second law, F equal ma. For that, we should know the actual forces acting on the particle. So the actual force acting on the particle are normal reaction and the weight. We don't need that. Compound of the weight along the slope down is mg sine alpha. The force that is opposing the motion, friction, is 400 Newton. Those are the two forces involved in the motion when you use F equal ma along the slope down. F equal ma along the slope down, I'm going to use it. Power is given, and also there's a thrust. Okay, one more force I didn't mark it, thrust, because engine is on, so there's a thrust. The thrust I can mark it Ft, the thrust force I can mark it Ft. Okay, I need to give the Ft in terms of power. We know that P equal Ft into V. You know that work done is equal to force into distance moved. If you differentiate, dW over dt is the power, dW, the rate of work done, is the power, F into dx over dt. Dx over dt is the speed. So T is the thrust given by the engine. So P equal Ft into V. So Ft, I need to find, I need to give it in terms of the speed, 16. So Ft is equal to P over V. So we know the power. Power is given as 15,000. Speed is given as 16 meter per second. So I can find the Ft there, or I can substitute the value later. Right, so we'll keep it as it is. So I'm going to use F equal ma along the slope down. F equal ma. What are the forces acting along the slope down? One is mg sine alpha, component of the weight along the slope down, plus Ft, the forward thrust given by the engine, minus friction 400 given, it's a constant force, equal to ma. Now we know all the quantities are given. We'll substitute the values. Okay, so mg sine alpha, mass is given as 900 kilogram, 900 into 9.8, sine alpha 1 over 12, plus Ft, that is 1500 over 16 minus 400 equal m. Mass is, yeah, I already used that. Mass is 900 times a. Find it. You will get 1.41 meter per second square. That's the answer. That's all. Okay, 1.41 meter per second square. Okay, question number 3, based on vectors. A particle P of mass 0.2 kilogram is moving with a velocity 4i minus 3j meter per second. So the initial speed is given 4i minus 3j meter per second. The particle receives an impulse of lambda I plus j. So the impulse is equal to lambda I plus lambda j Newton second. We can take a lambda out, where lambda is a constant. Immediately after receiving impulse, the speed of the particle is 7 meter per second. That means modulus of V, the final speed, its mod value is given, direction is not given, 7 meter per second. Find the value of lambda. Okay, you know that if you know a vector, for example, A is equal to xi plus yj, its modulus is given by square root of x squared plus y squared. The direction xi plus yj means in Cartesian coordinates. This is the I unit vector, this is the j unit vector. In I direction, the unit is a. Unit is a is equal to xi plus yj. Or we can say r is equal to vector r is equal to ai plus bj. Then modulus of r is given by square root of a square plus b square. The angle of the vector r is given by the ai means in the I direction, unit vector is taken along the positive x direction, that is a. Along the b direction, that is along the positive y direction, the unit is b. So the vector r is, this is the vector r. So the angle theta is given by tan inverse b over a. Tan theta equal b over a. That is the magnitude of vector, unit vector j over, in the vector b over vector a is the direction. Okay, so we'll use these ideas. So here the magnitude of the vector v, the final velocity is given. They have to find the lambda. Okay, we can do this in two different ways. First method, method one. First method, just by using I equal mv minus mu and algebra and vectors. Second method, by using vector diagram. We can sketch a vector diagram. Both methods will get the same answer. I'll do the first method. Normally, by using algebra, I is equal to mv minus mu. Okay, so mv, mass is given 0.2 kilogram. That also given in the question. Mass m is equal to 0.2 kilogram. Okay, we know the impulse vector, that is lambda I plus lambda j. Lambda I plus lambda j is equal to mv. So we don't know the velocity vector. Just we'll take it as v, that is 0.2 vector v minus 0.2 into vector u. We know that 4i plus 3j. So the idea here, I'm going to find the vector v. Vector v will be in terms of lambda. But we know the magnitude of the vector v, which is given as 7 meter per second. Magnitude is given by square root of, as I explained, a square plus b square. So from that I can get a quadratic equation for lambda. That's the idea. Nothing. It's very simple. Vector diagram is a bit difficult, but anyway you can get the answer. So vector v, we don't know, but we know the modulus of vector v. So I'm going to get a vector v, the final velocity, it's vector format I'm going to get. I'm going to find the magnitude by using the velocity vector, but magnitude I know that 7, so from that I can find the lambda. Okay, so rearrange it. So that means we can rearrange this. 0.2 v is equal to lambda I plus lambda j, bring it to the left, plus 0.24i plus 3j. Solve it, rearrange it. So it's going to be lambda plus 0.8, 0.2 into 4, 0.8. So lambda plus 0.8 I plus lambda minus, that is 3j, sorry, minus 3j. Minus 3j. So 0.2 into 6 is, that is going to be lambda minus 0.6 j. This is the 0.2 v. So divide the whole equation 0.2. 0.2 means how much? 2 over 10. That is, multiply the whole equation by 5. Multiply the whole equation by 5. So 0.2 will vanish. So v is going to be, it's going to be 5 lambda. Multiply the whole equation by 5. 5 lambda plus 0.8 into 5 is 4. 4i plus 5 lambda minus 3j. Okay, so what could be the modulus, mod value of v? So the modulus of v is equal to square root of 5 lambda plus 4 all things squared plus 5 lambda minus 3 all things squared. That's the modulus. So this vector r equal ai plus bj format. The modulus or magnitude of the vector r equal a squared plus b squared square root. This is the modulus of vector. But we know the modulus of vector v is given 7 meter per second. So modulus of vector v is equal to 7 meter per second. It's given there. Okay, both sides square it to remove the square root. So that will become 5 lambda plus 4 all things squared plus 5 lambda minus 3 all things squared equal 49. Square of 7 is 49. Okay, so now square it and rearrange it. You will get 25 lambda squared. You will get 25 lambda squared plus 5 lambda minus 12 equals 0. Rearrange it. Expand this, square it, and this 25 lambda squared plus 16 plus 40 lambda, like that you will expand it and solve it. You will get 25 lambda squared, 5 lambda minus 12. So you can factorize this one. If you factorize, or you can use the quadric, the CC, lambda will be equal to, use the calculator, 3 by 5 and lambda is equal to minus 4 by 5. Easy to use the calculator, you will get the answer. That's the final answer. They asked to find the lambda, this is the answer for the lambda. This is the method 1. Okay, method 2, vector diagram. You should know about vector diagram, how to find the resultant vector of two vectors when they are added or subtracted. For example, if they say vector R is equal to vector A plus vector B, you know a vector, the property of a vector, it could be shown by a straight line with an arrow. The length of the straight line indicates the magnitude of the vector. The direction of the arrow indicates the direction of the vector. Say for example, vector A is at an angle this direction, this is the vector A. Then vector B is this one, for example, this is vector B. Then the resultant vector, how to find, or the addition of the vector A and vector B gives vector R. How to find the vector R means, you know, first we can start with one of the vectors. Say I am starting with A. So after drawing A, from the end of the first vector, second vector should be started. If there are three vectors to be added, from the end of the first vector, second vector should be started. From the end of the second vector, third vector should be started. Then connect the most initial point of the first vector and the last point of the final vector. So vector A, I drew it first, parallel to A. Then vector B should be drawn from the end of vector A. This is vector B. It should be parallel to this one. The length of the vector B indicates the magnitude of the vector B. Then connect the point, initial point of the first vector and the final point of the last vector. That gives the vector R. Or if the vector A and vector B are given like this, how to find the addition of vector A minus B? R is equal to vector A minus vector B. How to find it? Vector A is along this direction. This is could be written as A plus minus B. Minus B, this is the vector B. Minus B means opposite direction. This is the minus B. This is the minus B vector. Okay, so A plus minus B. So draw the vector A first. Then plus minus B. Minus B is this direction. So from the end of the A, draw the minus B. Parallel to that, draw the minus B. This is the minus B vector. Then connect the initial vector and the final vector. You will get the final vector. This is R vector. Okay, so we are going to follow that idea in this second method. When we are sketching the vector diagram, then we are going to use cosine rule. Okay, so we are going to use vector addition rule and we are going to sketch, not draw. You can draw it according to scale, but based on time we can sketch it and use the cosine rule. So vector, you know that impulse is a vector I is equal to mv minus mu. We know that, that is mv plus minus mu we can show. So the addition of mv and minus mu gives the impulse vector. Okay, so mv, we know the velocity, we don't know the direction of mv, we don't know, but we know the magnitude of mv, we know that is 0.2, the mass is 0.2 into 7, that is 1.4 kilogram meter per second is the magnitude of mv, but we don't know the direction of it. We don't know the direction of vector mv, but we know the magnitude. Vector I is lambda I plus lambda j. So for vector I, the magnitude is square root of lambda square plus lambda square. That's the magnitude, is it? Lambda square plus lambda square square root. So it will be lambda times root 2. What's the direction of it? Lambda over lambda, tan inverse. I told that when I start the theory, tan inverse j component over I component. So that means tan inverse lambda or lambda, that is 45 degree. Tan inverse 1, that is 45 degree with horizontal line. So theta 1, 45 degree with horizontal. Okay, then what's the direction of mu? So the direction of u, look at here, 4i plus 3j, that is along the direction of I unit 4, along the direction of j, that is minus 3, j is minus because plus j is up, minus 3. So this is minus 3, so downward, this is 3 units. So the direction is downward, this is this is the direction of u, the u is in this direction. This angle we can find theta. So tan inverse 3 by 4. The magnitude is square root of 3 square plus 4 square. So we'll find the magnitude. So magnitude of mu is equal to 4 squared square root of 4 squared plus 3 squared times magnitude of m 0.2. That will be 5 into 0.2, that is 1 kilogram meter per second. That's the magnitude of mu. What's the direction of mu? So this we are getting this direction. My direction of mu will be along this direction because 4i, this is 4 unit along positive I, j negative. So the direction of mu, j is downwards, minus 3. So direction of mu is this way. This is the direction of mu, this angle theta, we can find it. So, but we are going to add minus mu. So minus mu is along this direction. Mu is along this direction, minus mu this direction. Anyway, we'll find the theta. So theta tan inverse 3 over 4. Tan inverse 3 over 4. You will get 36.87 degree. So mu is along this direction, minus mu. So minus mu, opposite direction. So minus mu along horizontal line. This is the direction of minus mu. This is the direction of minus mu. Minus mu. We found the direction of mu along this direction. Mu, we found theta 36.8. So this is 36.8 degree, opposite angle 36.87 degree. This is minus mu. Okay, so we need to find the vector I, which is equal to mv, addition of vector mv, but we don't know the direction of mv, but we know the numerical value of mv. mv minus plus minus mu, little hard I told so, but anyway we can do. So we know the direction of mu along this direction. mv we don't know, but I we know 45 degree. The resultant vector we know. So we'll think about the resultant vector first. We'll see the horizontal line. The resultant vector is ai. The magnitude of I told that is lambda square root of 2, which is 45 degree to horizontal. So this is the lambda root 2. This is 45 degree. This is the resultant vector, which is I equal to root 2 lambda, or lambda root 2. Root 2 times lambda outside the root 2. Okay, this is the vector I. So this is the resultant vector we are getting. When we add mv, we don't know, but mu, that makes an angle 36.87 degree with horizontal, and its magnitude 1 unit. So 1 unit from here, 1 unit from here, that makes an angle with horizontal here or here. This is 36.87 degree. This is a minus mu. This is the vector minus mu, which has magnitude 1. Direction this way, because minus mu is this way. I already explained that. Minus mu along this direction, magnitude 1 unit, because when you find that 4 square plus 3 square, that is the values of u coordinates 4 and 3. 4 and 3, square root of 4 square plus 3 square, you will get 5. 5 into 0.21. So that's the magnitude. 1 unit, 1 kilogram meter per second. Yeah. And the angle with horizontal 36.87. So when I connect these two lines, this point, that's the minus u vector. This is the I vector. If I connect these two lines, that will be the vector v. This is the vector v. Vector v, but we don't know its direction, but we know its magnitude, that is vector v 1.4. 1.4 kilogram meter per second is the magnitude of vector v. So this is vector v, vector mv. This is the vector mv. This is vector mu, gives the resultant vector I. Okay, what is this angle? So this is 45 degree with horizontal. This vector makes 45 degree with horizontal, means this is 45 degree. What will be this angle theta? So angle theta, we can find it. Angle theta is equal to 180, the whole line, minus 45 plus 36.87. So the theta will be equal to, you will get 98.13 degree. Okay, now we can name the triangle A, B, C. So in the triangle ABC, AB indicates resultant vector impulse, AC indicates MV, that indicates the vector MV. CB indicates the vector AC indicates vector MB, which is the magnitude 1.4. The magnitude indicates the length. The vector CB indicates vector minus MU, which has magnitude 1. So we can use cosine rule for the triangle ABC. Use cosine rule for the triangle ABC. So AC squared is equal to AB squared plus BC squared minus 2AB into BC cos theta. Is it? Cosine rule we can use for the triangle ABC. It's a vector triangle. So AC squared, that is 1.4 square, that is the magnitude of vector MB. Vector MB magnitude, we found it, 1.4 square is equal to AB square. AB is the indicates the vector I, its magnitude, vector I. So its magnitude is equal to square root of lambda square root of 2. I is given in the question, I is given. So its magnitude, lambda square plus lambda square, 2 lambda square, its square root. So root 2 lambda. So that is AB square root 2 lambda. So lambda root 2 whole thing square. BC is the minus mu. Minus mu is 1. So 1 square minus 2 times lambda root 2 times 1 cos theta. Okay, solve it. This is 1.4 square is 1.96 is equal to 2 lambda square. Then this is 2 into square root of lambda root 2 cos theta. So theta we had to substitute. This theta we found it 98.13 cos 98.13. Okay, now solve that everything. You will get 1.96 equal to 2 lambda squared plus 1 plus 0.4 lambda. If you solve these things, 2 into lambda root 2 into cos 98.13, you will get 0.4 lambda. Okay, rearrange it. So 2 lambda squared plus 0.4 lambda minus 0.96 equals 0. Find the value of lambda by using calculator. You will get 0.6 and 0 minus 0.8. 0.6 means 6 over 10, that is 3 by 5. Earlier we got that. Minus 0.8 means 8 over 10, that is minus 4 by 5. We got the same answer in the first method also. Okay, question 4 against vectors. At time t seconds where t less than 5 greater than 0, a particle p has a velocity. It's given a function of time in ij coordinates. When t equal lambda, particle p is moving in the direction parallel to the vector I. So the direction of velocity, directional vector of the velocity is given as I. So there's no j component for the velocity when the time t equal lambda. It's along I direction, so no j component. Find the acceleration of p when t equal lambda. So velocity vector is given. We know the directional vector of the velocity when t equal lambda, which is I, parallel to I, no j component. And how to find the acceleration? By differentiate the velocity vector, we can get the acceleration vector. So we know that the velocity vector is given as a part. Velocity vector is given as, that is 5 minus t square root of 5 minus t I plus t squared plus 2t minus 3j. So when the time t equal lambda, its direction is parallel to I. So that means when t equal lambda, direction of v is only along I. So it's clear, I and g are there, it's only along I means that velocity's j component should become 0. So I can say at t equal lambda, at t equal lambda, the j component, that is this component, that is t squared plus 2t minus 3 equal to 0, that is lambda squared plus 2 lambda minus 3 equals 0. At only during that time it has no j component, so that should become 0. I don't need to go to tan theta format. Simple, I can say that component equals 0 because only parallel to I. So factorize it. You can factorize it. This is lambda plus 3 into lambda minus 1 equals 0. So lambda equal 1 and minus 3. But time, lambda is a time, can't be a negative quantity. So lambda equal 1. So lambda equal 1 is the time, that is when t equal 1 unit, velocity is along only I direction. Lambda equal 1 means t equal 1, the velocity is only parallel to the I direction. The question is not that, but we have to find the acceleration. So differentiate now 1. Then after differentiating it, we need to substitute general format. Differentiate means you can't substitute t equal 1 now because that is at an instant. To get the acceleration vector, we need to keep the time there, otherwise you can't differentiate in terms of time. So we'll find the acceleration vector. So A is equal to dv over dt. We know the velocity vector, differentiating. So that's going to be half 5 minus t to the power half. So half within bracket, that means we can say 5 minus t to the power minus half into minus 1 is it. When I differentiate inside 5 minus t, there will be minus 1. That is I plus 2t plus 2j. This is the acceleration vector. If I want, I can solve it further. It will become minus 1 over 2 square root of 5 minus t I plus 2t plus 2 j is the acceleration vector. The question is, I need to find the acceleration. That is, I need to find the acceleration. That means they are not asking the magnitude of acceleration. The question says, find the acceleration of p when t equal lambda. So t equal lambda means we know the answer won't be in lambda. We know lambda equal 1. We found it. So we are going to get without lambda. But they asked to find the acceleration, means the acceleration vector. They didn't ask magnitude of acceleration. So acceleration vector means I need to find acceleration vector. This acceleration vector when t equal, when t equal lambda means lambda equal 1. We found it already. So substitute instead of t, which is 1. So that will become a, vector a is equal to minus, so if you put t equal 1, square root of 5 minus 1 is 4, square root of 4 is 2, 2 into 2 minus 1 over 4 I plus here 2, 2 into 1, 2, 2 plus 2, 4, 4 j. That's the answer when t equal lambda, that is t equal 1. Don't leave it in a j because we know the value of 1. Question 4, big part. The position vector of P is measured relative to O, relative to the fixed point O. When t equal 1, the position vector P is minus 2i plus j. So when t equal 1, the position vector is given by minus 2i plus j meters. Given that t less than capital T greater than 1 less than 5, find in terms of capital T the position vector of P when t equal capital T. Okay, so nothing. The idea here, you know that the previous papers also I already told that when you differentiate a velocity vector, you will get acceleration vector. When you differentiate position vector, you will get velocity vector. So other way, when you integrate velocity vector, you will get the position vector. So that means we know that dr over dt is going to be a velocity vector. So integral of dr is going to be integral of v dt. We know the velocity vector, it's given already, I wrote it. So square root of 5 minus t, that is integral of 5 minus square root of 5 minus t I plus t squared plus 2t minus 3 j dt. Okay, when we integrate, we need to assign constants for I and j separately because I and j are independent vectors among them. So the constants have to be given for I and j separately. So we'll integrate part by part, this I separately, j separately, easy to do that. So that could be written as integral of square root of 5 minus t I, or I can say that 5 minus t to the power of half I dt plus integral of t squared plus 2t minus 3 j dt. Okay, how to integrate this one? It's a normal thing. You can do a substitution if you want. That is, you can say capital X is equal to 5 minus t. So that is dx over dt equal minus 1. So that is dt is equal to minus dx. So this could be written as integral of 5 minus t. 5 minus t is x to the power half instead of dt, that will be minus dx. So that is minus integral of x to the power half dx. So minus x to the power half, you know that plus 1 if you add, it will become x to the power 3 by 2 over 3 by 2. Is it? X to the power 3 by 2 over 3 by 2. So that's going to be minus, instead of x you can substitute 5 minus t, 5 minus t to the power of 3 by 2 over 3 by 2. I am doing step by step, looks like long step, not necessarily. That is minus 2 by 3, 5 minus t to the power 3 by 2. That is the integration. Or you can directly remember the pattern, so you can put that way also. So that will become, this will become, if you integrate, will become minus 2 by 3, 5 minus t to the power 3 by 2 plus c1 I plus this one t cube over 3 2t squared over 2 t squared minus 3t plus c2, the constant c2 has been put separately, c2 j. Okay, so now we know that when t equal 1, r equal minus 2i plus j. So substitute, so this is integral dr, so we can replace dr, is it? Okay, so it's given that when t equal 1, r equal 2i plus j, substitute t equal 1. So if you substitute t equal 1, 5 minus 1, that will be 4, 4 to the power 3 by 2, 4 to the power 3 by 2 means half, is it 4? You can use calculator, I'm just doing without calculator. That means 4 to the power half means 2, 2 to the power 3, 8, is it? So it's going to be 2 by 3, 8. That is 16 by 3 plus C1. So that means I'll write it here. R is equal to, when t equal 1, t equal 1. So if I substitute this here, it will become 8. 8 into 2, 16 minus 16 over 3 plus C1 I C1 I plus, here when you put 2, t equal 1, 1 over 3, this is 1 minus 3, so that's going to be minus 2. If you solve, you will get 5 by 3 plus C2. J is equal to how much? Minus 2i plus j. It's given there. So that means minus 16 by 3 plus C1 equal minus 2. I should be same, j should be same. Therefore, minus 16 over 3 plus C1 is equal to minus 2. Find the C1. So C1 will be, you'll get 10 by 3. Same way, 5 by 3 plus C2 is equal to what? So C2 will be equal to 8 by 3. Check it. It should be minus 5 by 3, minus 5 by 3, so 8 by 3. Yeah, that's it. Minus 5 by 3. Okay, so C equal 8 by 3. Okay, so the general equation for R. So we can write the general equation for R by substituting C1, C2 here. I'll write it here again. So the general equation for R is given by R is equal to minus 2 by 3, 5 minus t, 3 by 2, plus C1, 10 by 3, I plus 1 over 3, t cube, plus t squared, minus 3t, plus C2, that is 8 by 3, j. So this is the general equation for position vector at time t. So they asked to find the position vector at time equal capital T. So instead of t, substitute capital T, you will get the final answer. So at t equal t, the position vector given by minus 2 by 3, 5 minus capital T, 3 by 2, plus 10 by 3, I, plus 1 over 3 t cube plus t squared minus 3t plus 8 over 3 j. This is the final answer, the position vector at time capital T. Okay, question number 5. This diagram is given. A uniform rod AB has length 8A and weight W. The end A of the rod is freely hinged to horizontal ground. Hinge. So there's a hinge here. The rod rests in equilibrium against a block which is also fixed to the ground. The block is modeled as a smooth, solid hemisphere. So no friction at point C. Hemisphere with radius 2A. So the radius is 2A. The hemisphere, the radius is 2A. And center D. The center of the hemisphere is D. The point of contact between the rod and the block C, where AC equal 5A, the rod is at an angle theta to the ground as shown in figure 1. Points A, B, C and D all lie in the same vertical plane. Show that AD equals square root of 29A. Okay, so they said the rod, uniform rod AB is touching a hemisphere at point C, means and D is the center of the hemisphere. So if you draw it in two dimension, it's going to be a half circle and C is on the circumference. This line AB is a tangent to the circle hemisphere. So whenever a rod or something touches the surface of the hemisphere, it will become tangent to the hemisphere or sphere. When you draw it on two dimension, it will going to be a circle. So AB is a tangent to the circle, half circle. So if it is tangent, when you draw a line from the center to the tangent, that will make 90 degree. You know that. It will make 90 degree with the tangent. A radius will make or will be perpendicular to the tangent drawn to a circle. So that will be 90 degree. The question is show that AD equals square root of 29A. So it's the ACD is a right angle triangle because this is perpendicular to, this is a radius, D is a center, it's going to be perpendicular to the tangent. So we can use Pythagoras theorem. AD squared, we'll consider triangle first, we'll consider triangle ACD. When we consider AD squared is equal to AC squared plus CD squared. AC squared 5A squared plus CD squared 2A squared. Very simple. So find that is going to be 25 plus 4, 29A squared. So AD is going to be A root 29. That's very simple, nothing. Right. So the B part. Show that the magnitude of the normal reaction at C when the rod and the block is 4 over 29 capital W. Capital W is the weight of the rod that will act at the center of the rod because it's a uniform rod. So the center of the rod means this is 5A, this is 3A, at a distance 4A. Somewhere here the weight will act vertically downwards. And it looks like a tangent to the circle, so I'll draw a little further. It's at 4A. So 4A, this is 8A, half of it. So this is 3 somewhere here. Okay, somewhere here maybe. I'll draw somewhere here, it's not a problem. So here the weight will act vertically down, which is W. So how much will be this angle? This will be, how much is this angle? 90 minus theta. Because this is 90 degree, the weight is acting vertically down. So in this right angle triangle, this is 90, this is theta, means this is 90 minus theta. Okay, so the normal reaction, the question is find the normal reaction. So the normal reaction will be, what do you mean by normal reaction? A reaction or contact force perpendicular to the contact surface. Perpendicular to the contact surface means contact surface is a hemisphere or like a two-dimensional circle. For that it's perpendicular, means it must be perpendicular to the tangent. So the normal reaction will act along the radius upwards. Along the radius upwards, that is the normal reaction, capital R, that is 90 degree to the circumference, or that will be along the radius of the hemisphere. Okay, so that is 90 degree. Okay, so we need to find that R. So it's easy. We don't know what are the forces acting at the hinge A. So better take moment, turning effect about A. Is it? We'll take turning effect about A. So when we consider turning effect about A part, B part, take moment about A. That advantage, we don't know what are the forces acting at A. When we take moment about A, that advantage, the unknown forces at A won't be in our equation, because the perpendicular distance to the forces at A from A is 0. So we can avoid the unknown forces at A in our equation. So only one unknown force will be there, that is R. And you know moment means force into perpendicular distance from the pivot. So we are taking A as a pivot. So clockwise moment if I take, so the weight is acting this way. This is the perpendicular distance to the line of action of the weight. That distance is equal to 5A cos theta, 5A cos theta. And we know that we can find the cos theta is not an issue. So 5A cos theta, 5A cos theta, is it 5A cos theta into W, or capital W, weight into W into 5A cos theta is clockwise moment. W into 5A cos theta is the length D, minus, because R will provide anti-clockwise, that is perpendicular from this A, this is the perpendicular distance, R into 5A equal to 0, because the rod is at equilibrium. 4A cos theta, not 5A, the distance center of mass is at 4A cos theta. 5A is from here to here, center of mass G of the rod is at 4A distance. So this is 4A cos theta. Okay, so what is cos theta? So if you consider this right angle, triangle A, this point is named as CACD, the triangle ACD, the triangle ACD, cos theta is equal to 5A over AD. AD we found it in the first part, that is A square root of 29. A and A get cancelled, so 5 over square root of 29 is the cos theta. So we'll substitute these values here. So W into A will get cancelled. 4 into cos theta, that is 5 over square root of 29 equal to, take it to the other side, 5R. So R will be equal to 5 and 5 get cancelled. R will be equal to 4W over square root of 29. That's the normal reaction at the contact point surface. Okay, part C, find the resultant force acting on the rod, rod at point A has magnitude of kW. So there are forces acting at the hinge. Its resultant force, or the resultant force at A, is K dime W and acts at an angle alpha to the ground. Find exact value of K is the C part, first part. Exact value of tan alpha is the C part, second part. Okay, so then I'll draw only the forces. I'm going to raise all the hemisphere, everything. I'm going to show only the necessary forces, the data. That is only the forces acting on the rod and the angle. So everything I'll draw it easy, because it's easy to handle by using only the required forces. Okay, I'll draw that now. Okay, I showed only the forces acting on it. The weight will act at a distance 4A from A. The contact point with the hemisphere C, which is at a distance 5A from A. The normal direction, we found it in the part B. The weight is acting vertically down. The angle with the horizontal is theta. Okay, so we know the sine theta. Already we found it in the previous part. Okay. The question is, we need to find the resultant force. So we don't know what is the direction of resultant force acting at the hinge. I can take just horizontally F1 vertically F2. I'll solve it and get the F1 F2. So I don't know actually which direction F1 F2 are acting. So I'll take horizontally towards right. The force acting is F1. Vertically F2. These are the actual forces acting on the B. I didn't show the part B because that we don't need. I showed only the center of mass and the contact point with the hemisphere. So the rod is moving beyond that also up to B. I didn't show it because I don't need it. There are no forces beyond C. We don't need them. There are no forces actually. Okay, so the weight is acting vertically downwards. Okay, so these are the only four forces acting, three forces actually, W, capital R, and there's a resultant force. That resultant force, you know, any force could be resolved into horizontal and vertical components. So I took the horizontal component of the resultant force at A as F1 and the vertical force F2. I'm going to find F1, F2. When I solve it, I might get F2 negative answer. That means it will be towards left. If F1 I might get negative answer, then it will be towards left. F2 also I might get negative answer, then it will be downward. So actually I don't know actual direction of force acting at A. I just took it towards right and up other components. When I solve it, if I get negative answer, I can change the direction. Okay, since the rod is at equilibrium, the resultant force acting on the rod AB must be equal to 0. And also when I resolve all the forces into any direction, it must be equal to 0. So we know this is theta with horizontal. So this angle is theta. Here this is theta, means this will be 90 minus theta, is it? Okay, we will resolve all the forces horizontally and vertically because rod is at equilibrium. Horizontal component must be equal to 0. Vertical component must be equal to 0. If you want, can take moment also, but I feel it's better take horizontal and vertical components, easy. If you take moment, one equation will have both F1 and F2. I don't want to have that. You can, no problem, but simplicity, I'm taking horizontal and vertically separately. So when I consider vertically, resultant forces must be 0, F2 minus W. When I resolve this one vertically, R sine, so plus R sine 90 minus theta, 90 minus theta cos theta. Cos theta, I know that because I already found in the previous part, we know that the right angle triangle, we used it like this. So this is 2a, the radius of the hemisphere. This length we found in the first part, that is a root 29. And this is 5a. This is theta. So cos theta is equal to cos theta equal 5 over 5a over a root 29 means 5 over root 29. Sin theta is equal to 2 over square root of 29. This is the triangle we got in the A part. This is A, CD. I didn't draw the hemisphere. Okay, so I can use this. So sin 90 minus theta cos theta. So R, I know 4W20 and substitute it and you will get the F2. So that's going to be, F2 is going to be, take to the right, W minus, instead of R I can substitute 4W over square root of 29 into cos theta, sin 90 minus theta, cos theta 5 over square root of 29. Solve it. Square root of 29, square root of 29 will be 29, 5 into 4, 20. So 29W minus 20W, that is 9W over 29. That is F2. Okay, then I'll resolve horizontally. When I resolve horizontally, F1, this is vertical force, has no horizontal component. This is vertical force, no horizontal component. This one will be minus R cos 90 minus theta equals 0. Cos 90 minus theta, sin theta also I know that. So F1 is going to be R, I can substitute 4W over square root of 29. Cos 90 minus theta, sin theta means 2 over square root of 29. That's going to be 8W over 29. So these are the components of the resultant force, actual force acting at A. But they are saying the actual force is KW. So I need to find the resultant force at A. I'll say RA, resultant force at A is equal to, if I know horizontal and vertical forces, the resultant force I need to use Pythagoras theorem, square root of F2 squared, F1 squared plus F2 squared. Is it? That's a resultant force of two perpendicular forces. F1, F2 are right angle among them. So square root of F1 squared, that is 81 W squared over 29 squared plus 64 W squared over 29 squared. So solve it. You will get square root of that will be square root of 145 W over 29. Anyway, we can, 145 divided by 29, you can get an answer, simple. So this I can write equal to square root of 145 over 29 squared. W. 29 square could be written as 29 into 29. So 145 over 145 over 29 square means 29 into 29 square root. 145 over 29 is 5. That is equal to, this we solve this, 5 over 29 square root. You can write that way. So finally the RA is going to be, so 29 square could be written this way. So finally RA, the resultant force at A, I'll raise it. So resultant force RA going to be, if we solve it, 29 will get cancelled, so it's going to be square root of 5 over 29 W outside the square root. The question paper says the resultant at A is K times W, so this is equal to K times W, the question paper says. So therefore they have to find the K equal to square root of 5 over 29. That's the final answer. That is the answer for C part, first part. C part, second part, find the angle alpha. They are saying the resultant force make an angle alpha with horizontal, find the tan alpha. So tan alpha, we know the horizontal component F1 and the vertical component F2. We know that, we already found it, F1 here, F2 here. So we need to find the tan alpha, so that's not an issue. Okay, C part, second part, they have to find the tan alpha. Tan alpha is the resultant force at A. So this is F1, this is F2. The resultant force at A, that is RA, resultant force A, I use RA for the resultant force, which take an angle alpha. So tan alpha equal opposite, that is vertical component of the force F2, tan alpha is equal to F2 over F1. F2 we know that is 9W over 29, 9W over 29 divided by F1, that is 8W over 29, that is 29 over 8W, it becomes plus. Okay. So 29 will get cancelled, 9W over 8W, 9 over 8. So from this, tan alpha equal to 9 over 8. That's the final answer. Okay, so this diagram is given, question number 6. The uniform laminar PQRSTUV shown in figure 2 is formed from two identical rectangles PQUV and QRSTU, right? The rectangles have sides PQ is equal to RS, so PQ is equal to RS, which is 2A, and PV is equal to QR, that is KA. Show that the center of mass of the lamina is this much from PV, from P. So it's not a point. Go through the first question. I explained the center of mass briefly, the theory, so you can go through it. First question before that, so I'm not going to explain the theory again. Okay, so we need to find the center of mass of this uniform lamina from the line PV. Yes, so sigma mi XIO, sigma mi. So we can take mass per unit area as rho. So the mass per unit area of PQUV, we can take it M1, so that is A part. M1, that is the mass of PQUV. M1 is equal to the area Ka into 2A, so 2Ka squared rho. Same way the mass of M2 also the same, so M2 also the same 2Ka squared rho, because they have the same length and width. Okay, so yes. Now we'll find the center of mass of PQUV from the side PV is A. This A this is the center of mass of this rectangle. So G1 is the center of mass. Its distance from the side PV is half of 2A, that is A. The center of mass of this rectangle from this side is at Ka by 2. This is Ka. The center of mass will be exactly at the center, uniform. So the distance of the center of mass from this side is Ka by 2. From here, 2A plus Ka by 2. 2A plus this is Ka by 2. That's all. Solve it, you'll get the answer. So you know sigma, that is total mass M into x bar equal sigma mi xi, sigma mi xi. That's a definition of, I don't want to go away from the definition of center of mass. That's a mathematical definition. So that is M1 x1 plus M2 x2 equal, M is the total mass. Total mass, we need to add the two masses. So that is, M is going to be Ka squared rho plus Ka squared rho. That is 4 Ka squared rho times x bar is equal to M1, that is 2Ka squared, 2Ka squared rho, half of 2A, so into A, plus for the other one, M2 also the same mass, 2Ka squared rho into the distance Ka by 2 from here, Ka by 2 plus 2A. So 2A plus Ka by 2. So everywhere A squared will get cancelled. There will be A remaining here, because here there will be A cube, doesn't matter, because we are going to get the final answer in terms of A. So it's going to be, we can divide the whole equation by 2Ka squared. So if I divide 2Ka squared rho, it's going to be 2x bar equal to 2Ka squared rho. We divided, so A plus 2Ka squared rho. So here 4A plus Ka by 2. So x bar is equal to A by 2 plus 4A plus Ka over 4. Okay, solve it. You'll get the answer. You will get 2A over 4. Is it 2A plus 4A? 6A plus Ka by 4. That is 6. The answer says 6 plus K. A over 4 is the x bar. Okay. So this means this answer for the first part. We don't know the actual point. I explained it in the first question. Go through it. We don't know the actual point where the center of mass. We know the distance of the center of mass from K. Somewhere, if I know the value of K, we don't know, but it will be somewhere here. The center of mass of this system is somewhere here at a distance along this line, which is at a distance of 6 plus K into A over 4. Somewhere on this line, we don't know. If I want to find the actual point, I need to find the distance of the center of mass from this line, from the x-axis. That is, I should find the y coordinate. This is x coordinate of the center of mass. I should find the y coordinate, where the y coordinate, the distance, and this line intercept. That will be the center of mass. We need to find for the second part. Okay, so this is the answer for the first part. Okay, second part. The lamina is freely suspended from P and hangs in equilibrium with PR at an angle of alpha to the downward vertical. Given that tan alpha, we need to find the K. Okay, anyway, whatever it is. For that, you know, there will be a center of mass. There will be a point, exact point, that will be the center of mass. When we hang some lamina, it could be a uniform or non-uniform object from a point. What happens? The center of mass will, the whole object will rotate until the center of mass comes exactly below the point from below the point from where we are hanging the object. Say for example, if there's an object, this is an object, non-uniform shape object. If the object has center of mass here, G, I just normally use center of mass G, and it's hung from point P and freely hung, so it can rotate, no friction. When you leave it at level, it won't stay like this because the weight will act at this point. If you do this at space where there is no gravity, it will stay there. If it is in deep space where there is no gravity from any other planets or any stars, it will stay at the point where you keep it. But here, due to the weight will act at point J. So weight is acting here. You are hanging from this point, means there will be a clockwise moment, so it will rotate until the moment become equal to 0, because when object is at equilibrium, total moment must be 0. So it will rotate until G comes below. So it will come like this. So this is the point P, somewhere here P. So the G will be exactly below, such that the weight acts along the line of action of the normal reaction from the point we are hanging, maybe a nail or somewhere. So anyway, you should know it will rotate until the G comes below the point of hang. Yeah. So here also, they are saying they are hanging from point P. We don't know the actual point of center of mass. If I know, I can say the center of mass will be exactly below P. And they are saying the line PR is making angle alpha, PR at an angle alpha with the downward vertical. Downward vertical means I don't know the center of mass. If I say the center of mass of this lamina is somewhere here, the center of mass of the whole lamina is here. So this line P to that center of mass, this line will become vertical. With that vertical, PQ will make an angle alpha. So P to that center of mass, I don't know where I am going to find it. The point G is the center of mass of the lamina. That point G will become below P. So it will rotate. So this whole system will rotate until G becomes below that. So that point is the point exactly below the point of P. With that vertical line, they are saying PR is making an alpha. So that means I don't need to draw such that this is below, and I don't need to rotate and draw. I can imagine this line will be vertical. With that line, PR makes alpha, means I need to find this alpha. Is it? For that, I should know the exact point at which the center of mass exists. How to find it? I know the x coordinate or the distance of the center of mass from PB, I know that. X coordinate of the center of mass, I know that. Now I need to find the y coordinate of the center of mass from the line PR. Same thing I have to do to find y bar. Then where the x bar, what I found here, and the y bar intercept, that will be the exact center of mass. Okay, so as I told, I need to find the y coordinate of the same center of mass. A lamina can have only one center of mass, one point, is it? One center of mass. So now we are going to find the y coordinate. So that one is given by m y bar, same mass, is equal to m1 y1 plus m2 y2. Okay, so capital M, that is 2ak squared plus 2k squared, 4k a squared rho y bar, we are going to find it, is equal to m1, that is 2k a squared rho y1. For this, now we are going to find from PR, we are finding it from PR, so the distance is ka by 2 half. For this lamina, for this rectangle, ka by 2 plus M2, same mass, this one, 2Ka squared rho. Its center of mass from PR is half of 2A. From here, half of 2A, that is A. Okay, so solve it and we need to find the y bar. So this is going to be whole thing we can divide again by 2Ka squared rho. So 2Ka squared rho means 2 y bar is equal to Ka by 2 plus 2K squared plus A. So that's going to be Ka plus 2A over 2. So y bar will be equal to finally Ka plus 2A over 4. That is K plus 2A over 4. So I know the y bar also. So I know there's a point for which this is the center of mass. I'll take this is the center of mass. Its x coordinate, this one, 6 plus k over 4 into a. Y coordinate, its y coordinate is this one. So the y coordinate, this distance, this length, the y coordinate, I'll erase these things anyway, now I don't need. This is k plus 2 a over 4. So I know this length. So I know this length. So at this point I don't need any of these things now. So in this right angle triangle, I'll consider right angle, this name the center of mass, I'll name it capital G. That's the final center of mass. This point I'll name it N. So in the right angle triangle, so PG, this is the G, this point is G. PG will become vertical. With that, PR is making an angle alpha. Is it there? It's given in the question. So R, I'll keep it there. So PR is making an angle alpha with vertical line, means PG will be the vertical line. PG is the vertical line. I already explained several times. So tan alpha, I need to find the tan alpha is equal to, in this right angle triangle. So this is the vertical line. This will be make an angle alpha, means consider that right angle triangle PGN. PN, that is 6 plus k over 4 into a, already we found it in the a part. That's the x coordinate of the center of mass. GN, this NG is this one. So tan alpha is equal to NG over PN. NG means k plus 2 a over 4 divided by 6 plus k over 4. So I'll put it into 4 over 6 plus k a. So that will be k plus 2 a and a will get there. K plus 2 over k plus 6. K plus 2 over k plus 6, and it's given in the question tan alpha 7 by 15. So tan alpha 7 by 15, 7 over 15 it's given. 7 over 15 cross multiply 7k plus 42 equal to 15k plus 30. Now solve it for k. You will get the final answer k. Right, so solve it. So you'll get k is, you know how to solve, that is 3 by 2. 1.5. That's the final answer. They asked to find the value of k, 3 by 2 or 1.5. Okay, question 7 based on momentum head-on collision. Particle A of mass m, particle B has mass 2m. The particles are moving in the same direction along the same straight line on a smooth horizontal surface. Particle A collides directly with particle B. It's a head-on collision. Immediately before collision, A speed is 3u and the B is u. The coefficient of restitution between A and B is A. Show that the speed of B immediately after collision. Okay, we'll put it on a diagram. It's easy to handle with diagrams. So A is mass m moving at a speed 3u. B in the same direction they are moving, 2m u. This is B before collision. After collision, A mass m moving at v1, we don't know, we are going to find it. This is 2m b moving at v2 after collision. So the question is, A part, show that the speed of B immediately after collision, something we have to show 5 plus 2e, find the speed of A immediately after. So here, we don't know both velocities after collision, but we know one more data, that is, the coefficient of restitution during collision is E, that's given. So we are going to get two equations. One is by using principle of conservation of momentum or law of conservation of momentum. The second equation by using the experimental results made by Newton, that means we call Newton's experiment for impact. By using it, we are going to get the second equation. So there are two unknowns, V1, V2. We have two equations. Solve it and get V1 and V2 separate. That's all, not a big issue. So there we can write the answer. A part, first part. We'll write law of conservation of momentum. We'll write it towards right, positive. So that means m into 3u plus 2m into u is equal to m into v1 plus 2m v2. So all the m will get cancelled. We'll get an equation v1 plus 2v2 equal to 5u. Now we are going to use the experimental results for impact. That is what it says. Speed of separation, that is relative speed of separation, is equal to E times relative speed of approach. Speed of separation means relatively speed of separation after collision. Always speed of separation happens after collision. Speed of approach happens before collision. So speed of separation after collision means this is greater than this. Otherwise this will hit with it after collision. Again there will be collision. So V2 greater than V1. So speed of separation V2 minus V1 is equal to E into speed of approach. This must be greater than this. So this will approach this with the relative speed of 3u minus u. Okay, so that means V2 minus V1 is equal to 2EU, second equation. So we need to find, first part, show that the speed of B, that is I need to find V2. V2 I need to find. So first equation V1 plus 2V2, V2 minus, so add first two equation, minus V1, V1 will get cancelled. So V2, 2V2, it will become 3V2 is equal to 5U plus 2EU. So V2, solve it, will be, you can take the U out, 5 plus 2E, U over 3. That's the answer for first part. A part, first part. A part, second part. Substitute this in equation 2, second equation. So that is A part, second part. Substitute. In equation 1. So if you substitute, that is 5 plus 2e into u over 3 minus v1 equal to eu. Okay, solve it. You know how to solve it. That will be 5u plus 2eu. When you bring it to the left, it will become minus 2e minus 6 eu over 3 equal v1. So v1 will be equal to 5u minus 4, is it 4 eu over 3. You can take the u out. 5 minus 4e u over 3. That's the speed of A after collision, immediately after collision. Okay, same question, B part. After the collision, B hits a smooth fixed vertical wall that is perpendicular to the direction of motion of B. The coefficient of restitution between B and the wall 1 over 3. Particle B rebounds and there is a second collision between A and B. So actually A has greater velocity, we found it. So the B has greater velocity, we found it. So B is moving at greater speed than A after collision towards a wall, hitting the wall and bouncing back. A is still moving. So again, the second time A and B are going to collide. The first collision between A and B occurs at a distance symbol D from the wall. The time between the two collisions is capital T. Given that E means the coefficient of restitution between A and B. Earlier what we used in the equation A part, E 1 over 2. But for the collision between the ball B and the wall is 1 over 3. This is between ball A and ball B, or the particle A and particle B is 1 over 2. Find capital T in terms of D and U. Okay, so we can put it on a diagram. So we'll find the velocities V1, V2 again. So V1, now they are saying E is equal to half. They are telling it E is equal to half what we got. So we'll find from the previous part. V1 we got it. V1 we got the equation. V1 is equal to 5 minus 4E U over 3 we got it. Substitute half here. So half means 2. Is it 5 minus 2? That is 3. 3 and 3 will get cancelled. So that's going to be U. I'll put it on a diagram again. So V2 we found it. V2 we found it. 5 the equation we got for V2. Yes, that is 5 plus 2E. 5 plus 2E U over 3. Substitute half here. Half means E is half means 1, 6 divided by 3, 2, 2U. So both particles A and B are moving towards the wall. The speed of B is 2U and speed of A is U. Note down, I'm going to erase it and I'm going to put it on a diagram again. I'm going to draw a diagram again with the wall. If I put it on a wall, so these are the velocities of A and B after collision since we know the E. Okay, right? So B has greater speed than A. So if I put it on a diagram like this, immediately after collision, if I draw the particles, this is A, this is B. They are immediately after collision, so small gap I show. So this is A, this is B. B has velocity 2U, we found it now. A has velocity U and the wall is at a distance D from the point of collision. So they are very close, so there's a gap but doesn't matter. So they are at a distance D from the point of collision. Now the speed of B is twice the speed of B. So if B takes a certain time to hit the wall or reach the wall, when the B takes a time to reach the wall, when the B hits with the wall, at what distance will A move? Half of it, because speed of the A is half of the speed of B. So when the B touches the wall, when the B is hitting the wall, when the B is hitting the wall and it's bouncing off at a speed V3, A will be at a distance, how much from wall? It will be at a distance, because when B travels towards the wall at a speed 2U, this will travel during the same time half the distance. So when B travels, for example, when B travels a distance 10 meters, during that time A can travel 5 meters. If B travels a distance of 20 meters, B travels a distance of 20 meters during a particular time. During the same time, this can travel half of it, 10 meters. So if B travels a distance D and hits the wall, it can travel only D by 2. So the ball A will be at a distance of d by 2 from the wall. What could be the speed V3? What would be the speed V3? So V3, again I can use the restriction, the experimental results. The speed of separation V3, the wall is at rest, speed V3 minus 0 is equal to E into speed of approach. Before hitting, the speed of B is 2U, E into 2U, wall is anywhere S minus 0. So V3 equal E times 2U, but E we know 1, 3, so 1 over 3 times 2U, so that is 2U by 3 is the speed of the ball B after collision. Okay, so when the B hits with the wall, it will bounce off with speed 2U by 3. At that moment A will be at a distance D by 2. How long B takes to reach the wall? So we'll find that. I said it will travel a distance D. Time taken by B to travel A, time taken by B it's moving at constant speed. We know speed equal distance over time T1. So T1 will be D over 2U. So that's the time taken by the ball B to reach the wall. During this time, ball A traveled a distance of D by 2 and it is at a distance of D by 2. Okay, now the B is traveling towards A at a speed 2U by 3. A has the speed U. Its speed is not changing, moving at U. Now they are going to collide again. How long will it take for A and B to collide again when the B bounces off from the wall? Okay, how to find it? We can use relative speed. But if you are not familiar with relative speed, that means when two cars are moving in the opposite direction, 2 meter per second, 3 meter per second, speed of this one related to this is 5, speed of this is related to this is 5, opposite direction. So we can use relative speed. But anyway, if you are not familiar with relative speed, we will take, how long will they take to collide? But anyway, when they collide from this moment, when the ball just bounces off from the wall, at that moment ball A is at a distance D by 2 from the wall at a speed U, this is at a speed 2U by 3. When they collide, the total distance traveled by them is D by 2. We don't know at which point they are colliding, we don't need, but the distance traveled by this and distance traveled by this will be equal to D by 2. If you add the distance traveled by A and B, when they collide again, will be equal to D by 2. So the time taken by them to collide again from this moment, let it be T2, symbol T2. So during the time T2, the total distance traveled by both A and B, that is equal to D by 2. So we'll take that way. So the time taken for both A and B to collide when B bounce off from wall equal T2. So during the time T2, how much will A travel? Speed equal distance over time, speed equal distance over time, distance equals speed into time. So what distance will it travel? The distance traveled by A during T2 is equal to distance traveled by A during that time is equal to U into T2, U into T2. Distance traveled by B during the time T2 equal to V3 into T2, V3 into T2. So the total distance traveled when they collide is D by 2. So U T2. Instead of V3, I can substitute 2U by 3, T2 equal D by 2. So we'll find the T2 now. So that will be 5, I'll continue here, 3 plus 2, 5u over 5u, 5u t2 over 3 is equal to d by 2. So t2 will be 3d over 10u. Okay, the question paper says the total time from the moment they collide first time to collide again, the total time is capital T, they are telling it. The total time is capital T. So that means T1 plus T2 equal T. T1 d over 2u plus 3d over 10u equal T. So T is equal to, solve it. So it's going to be 8u. That's not simple, is it? So you can divide by 2, so that's going to be 4d over 5. Okay, so the question number 8, this diagram is given. A rough ramp is fixed to horizontal ground. The ramp is inclined to the ground at an angle alpha, where tan alpha 7 by 24. The point A is at the bottom of the ramp and the point B is at the top of the ramp. The line AB, yes, is a line of greater slope of the ramp, AB 15 meter. A particle P of mass 0.3 kilograms projected with speed u meter per second from A directly towards B. At the instant P reaches the point B, the velocity is 24I plus 7j. So at B, it's horizontal component. So the speed here, and when it reaches this point, the V is equal to 24I plus 7j. 24I plus 7j. So the horizontal component towards right is 24, vertical component vertically upwards 7 meter per second. The particle leaves the ramp at B, so it's projected on a ramp, it's moving along the ramp, then it's leaving the ramp at B, then so after that it's going to move on a projectile path. The coefficient of friction between P and the ramp is 105, mu is given. Find the work done against friction as P moves from A to B. So it's a very basic thing, A part. Work done against friction. We can say WFR, not a standard notation, I am using it. Friction force into distance moved opposite to the friction. What's the friction force? Mu R. Because it's when it is moving, the friction will be limiting friction because it's in motion. Otherwise, it could be smaller than limiting friction. But since it's in motion, it must be equal to limiting friction into the distance it moved. That's anyway 15 meter. What is R? When an object is kept on an inclined plane, the weight will act vertically down mg. If it makes an angle alpha, this angle will be 90 minus alpha. Component of the weight along the slope down is mg sine alpha. You must know component of the weight perpendicular to the slope will be mg. This is 90 minus alpha. I mean sine away. Sine 90 minus alpha cos alpha. So the normal reaction will be this way. Since there is no motion perpendicular to the slope, there could be motion along the slope. Since there is no motion perpendicular to the slope, the resultant force must be 0, means R minus mg cos alpha. When you consider perpendicular to the slope, R minus mg cos alpha equal to 0. So R must be mg cos alpha. R must be equal to mg cos alpha. So here mu R, so this I can write mu mg cos alpha into d. Okay, so here tan alpha is given 7 over 24. So when you consider the right angle triangle, this is alpha 7 over 24. So if you use the Pythagoras theorem, you will get this is 25. Now I can find sine and cos also. Okay, so that is going to be, we'll substitute, mu is given 1 over 3, 1 over 5. Mass of the particle is given as 0.3. 9.8 is G. Cos alpha 24 over 25 into D 15. This much of joules, solve it. You will get 8.47. That's the first part answer. A part. Okay, B part. Use the work energy principle to find the value of U. So we know the speed at B. We can find the speed at B. We know the components of the speed. So B part. Speed at B. V is equal to square root of 24 squared because 24I plus 7J 7 squared. So we need V squared because when we use energy equation there will be kinetic energy. So we need V squared. So V squared is equal to, if you solve you will get that will be equal to 625 meters squared S minus 2. Right, okay. So we'll use the energy equation for the motion A to B. When it moves along the planar, there will be loss in kinetic energy because there is a friction, so there is loss in kinetic energy. So the kinetic energy will be lost and that will be converted into gain in GP. So the height is increasing, so there is a gain in GPA. When it moves from here to here, this is the height H. That is going to be 15 sine alpha. This height is going to be BC, H, that is 15 sine alpha. Okay, so it's going to lose kinetic energy, it's going to gain gravitational potential energy. Also, there will be work done against friction. So what will happen to the loss in kinetic energy? You have to identify the energy changes. If you want, you can equate the initial total energy, final total energy, but you know you can't measure the gravitational potential energy. Otherwise, if you want to measure the gravitational potential energy, you have to measure the distance from the center of Earth. As a physics teacher, I should say that way. So normally what we learn, mgh is not a gravitational potential energy, that is the change in gravitational potential energy. I don't want to go away from the actual physics. Even it's maths, we have to, I want to stick to the actual physics. So change in gravitational potential energy is mgh, not the gravitational potential energy. Actual gravitational potential energy means it should be measured. H must be measured from the center of the Earth. Anyway, so that's the reason I am using loss gain format. So when it moves from this point to this point, it's gaining gravitational potential energy because its height is increasing from here to here. The increase in height is H. So we can say it's losing the kinetic energy. Loss in kinetic energy is equal to gain in GPA, gain in gravitational potential energy plus that's work done, because the work done is due to loss in K. If the particle is at rest, there won't be any work done against friction. What's the outcome of work done against friction? Sound and heat. So there is work done against friction. I put WFR because I already defined WFR here, work done against friction. Okay, loss in kinetic energy, initial kinetic energy, half m u squared minus half m v squared. Loss means initial minus 1. Gain in GP, mgh, h I already defined here, plus w fr. So we'll substitute now. Half into, we know the mass, that is 0.3 u squared minus half 0.3 v squared 625 equals 0.3 9.8. H is 15 sine alpha, 15 sine alpha. So sine alpha, again that is the triangle. If I draw, I erased it. We know the tan alpha is given 7 by 24, 7, 24, this is 25. So sine alpha, is it? Sine alpha means 7 over 25. plus work against friction, we found it, that is 8.47. Okay. Okay, solve it and find the u. All numbers, only u is the unknown. Solve it, you will find the u, that will be 27.6 meter per second. Okay, so C part, find the time taken by the particle P to move from B to C. See, when it reaches the end of the ramp B, it's going to follow a projectile path. So when it reaches the point B, we know the velocity, horizontal component of velocity 24, vertical component 7, J means vertically upwards 7 and horizontally 24 meter per second. Okay, so they have to find the time taken. So C part, we can use downwards, S equal ut plus half at squared for the motion from B to C. We'll consider the motion from B to C. Okay, when we consider the motion from B to C, the displacement is B to C is 15 sine alpha. 15 sine alpha is the vertical displacement. U is vertically upwards. I am taking downwards positive. So minus 70 plus half into G 9.8 downwards T squared. Sine alpha, I know that 7 over 25. So 15 times 7 over 25 equal minus 70 plus half into 9.8 T squared. Okay, rearrange it and get a quadratic equation. You will get 4.9 half into 9.8, 4.9 T squared minus 70 minus 4.2 equals 0. Solve it by using calculate an equation mode. You will get T equal 1.88 seconds and T equal minus 0.46 seconds, but it can't be because negative time is always positive, so the time taken is 1.88 seconds. That's the answer. That's the answer for C part. D part, at the instant immediately before P hits the ground at C, where it hits the ground C, the particle is moving downwards at theta to the horizon. So it has a velocity along the tangent, is it? When it hits, it has a velocity along the tangent. It makes an angle theta with horizontal. So they have to find the theta. Okay, so we know that when it leaves the point B, that means when it starts the projectile motion, horizontal component 24. So horizontally there is no acceleration, no deceleration. We ignore the or neglect the drag force. So horizontal component of the velocity will remain unchanged throughout the motion of the projectile particle. But only the vertical component of the velocity will change due to gravitational acceleration. So we'll find only the vertical component of the particle just before it hits the ground. Horizontal component will be the same. Then if I know both horizontal component, which is going to be 24, no change, vertical component if I know, by using vectors, that is if I know two right angle components, I can find the angle of the resultant velocity. I'll do that now. So D part, downwards we'll use V equal U plus AT. That is vertical component I'm going to use. That is initial velocity is upwards. I'm using downwards positive. So minus 7 plus acceleration is downwards. Time taken is 1.88. So when I solve, I'll get the vertical component of the velocity, which is 11.4 meter per second. Horizontal component has no change. So the horizontal component just before it hits the ground, same as initial, because no change in horizontal. Vertical component downwards, 11.4 meter per second. The resultant velocity or the velocity at which it hits the ground is V. That makes an angle theta with the horizontal. So it's a vector. Velocity is a vector. Horizontal component 24, vertical component 11.4, meter per second. This is the velocity I'm going to find. I'm not going to find the velocity, the angle. This angle I need to find it. So tan theta, this is right angle triangle, tan theta opposite 11.4 over 24, find the theta. You will get 25.4 degree. That's the final answer. Because this angle, both same opposite angles. Okay, so that's all. This October 2022 Edexcel IAL Mechanics M2. I hope you understood. Okay, so we'll meet again during some other discussions. Bye.